Good afternoon, everyone. My name is Pavan PS, a Masters of Computer Application student at Chanakya University, Bangalore. Today I am presenting my IE research paper on loan approval prediction using a logistic regression, a machine learning approach to automate and improve credit decision making in banks. Here is the roadmap of today's presentation. We will cover 8 sections, starting with the problem's motivation, then the dataset, pre-processing steps, the logistic regression methodology, model training, our result, a critical decision, and finally uh, conclusion with the future directions. The core problems is the traditional loan evaluation is done manually. It's time consuming, prone to human bias, and inconsistent across loan offices. Banks urgently need automated system to access credit worthiness quickly and fairly. Our solution is to apply logistic regression on a real-world dataset of 367 applicant records with 12 futures to predict credits, history, outcomes, and automate loan decision consistently. The dataset contains 367 records and 12 futures covering applicant demographics, income, loan amount, and credit history. Notably, 83.4% of cases are loan approvals, meaning the dataset is imbalanced. There are no applicants ROS, which is good. However, several futures have missing values. Most critically, credit history has 29 missing values, which is our target variable, making pre-processing crucial. We handled pre-processing in 3 steps. Step 1, missing values are filled using forward fill, which is propaganda, the last valid value, preserving the futures distribution better than using a mean. Step 2, all 7 category columns like gender, married, and education were converted into numeric codes using label encoding from scikit learn. Step 3, future scaling using standard scalar was applied to ensure zeros, means, and until variance. This is critical for logistic regression, which uses gradient descent internally. Logistic regression is ideal for binary classification. It uses the sigmoid function to map any inputs to a probability between zeros and ones. The formula shows maps the weighted sum of futures to a probability. If it's above 0.5, the loan is approved. We uses L2 regularization controlled by a parameter C. To prevent overfitting, we tested two configurations. The default model with the C is equal to C is equal to 1.0 and a tuned model with the C is equal to 0.5 and 1000 iterations uses the IBFGS solver. The data was split 80% training and 20% testing. This slide shows the complete Python training pipeline. We import pandas and scikit learns pre-processing and models tools. Apply forward fill, encoded categorical columns, scale futures, then they train the logistic regression model with C is equal to 0.5 and max iter is equal to 1000. The four keys design choice highlighted are Credit history has the binary target C is equal to 0.5, regulation to reduce overfitting, 1000 iteration to ensure convergency, and a standard scalar for gradient stability. Over a result are tracking 100% classification accuracy on the test set. The model was trained on 293 samples and tested on 74. Both the default and tuned configuration achieved this result. The positive class makes up 306 of 367 records. It means 83.4 percent, and there were 61 negative class instances. 100% of 100% accuracy sound impressive, but we need to be honest about this implication. First, it likely reflects the linear separability in the encoded data. Second, with this 83.4% positive class imbalance, a model that always predicts the approved would already get 83% of accuracy. So accuracy alone, it's not enough. We recommended F1 score and AUC ROC. Third, and most importantly, there is a potential data leaked issue. Credit history was used as both the target variable and a remind in the future metrics during encoding, which could inflect result. Finally, with only 367 records, stratified k-fold cross valid is recommended. Here is a conclusion. To memorize, we processed a 367 records datasets end to end. Build a logistic regression model with the clean pre-processing pipeline and achieved 100% test accuracy through with important caveats discussed. Credit history is the strongest binary predictor for future work. We plan to test ensemble model like random forest and XGBoost, apply stratified k-fold validation, address classes imbalance with the smooth, add explainability using a shop or a limb, and ultimately deploy the model as a REST API for real-time loan discussion. Thank you.